Okay, so today what we're talking about is factoring polynomials, all right? These are pretty easy. They really are. So this is a new type of factoring that you haven't done, but it's not hard. Trust me on this, okay? If you have a cube plus a cube, this is different though, and I want you to make sure you guys understand. This is different. This is a different problem than this. These two are totally different questions. This one's a multiplication process, right? This one would be a plus b times a plus b times a plus b, correct? This would take Pascal's triangle. It'd be a big, long answer. This is an a cubed plus b cubed being factored. See the difference between the two questions? Okay, this is a totally different question. This is going to take a big, long multiply, okay? This one's factored, okay? So the way you factor a cube plus a cube is you've got a little formula. It's just going to be a plus b times parentheses a squared minus ab plus b squared, okay? Now, how does this little formula work? Well, first of all, let's look at example 1. This is a cube plus a cube. This is a cubic number. What cubic number is this?
3.
3. Good. So let's rewrite this as x cubed plus 3 cubed. Are we okay with that? Does that make sense? And now to factor this, all we're going to do is take my x and let it be my a values, and let my 3 be my b values. So in this case, my x will be my a values, and my 3 is going to be my b values. I'm going to put those into my little formula. That's all. So I'm going to go parentheses, and I'm going to use my formula. Here's my formula, okay? A plus b. Well, I'm going to go x plus 3. Okay, I'm using my formula. A plus b. A is x and b is 3, okay? Plus x plus 3. Then times a squared. Well, a is my x, so I'm going to go x squared minus ab. That means those two multiply together. So what is x times 3? Well, it's just going to be a 3x minus 3x plus b squared, and b is 3. 3 squared is 9. It is factored. Done. If I were to multiply, and I won't, but if I were to multiply this all out, this times this, this times this, this times this, I would get x cubed plus 27.
Oh, that's what you do? A lot, really?
Yeah.
Sweet, dude.
It's easy, isn't it? Let's do the second one, okay? Now, we have a formula for subtract. There's two ways to do this. One is to not give you another formula and just say let b be a negative, but that's a little confusing. So let's just do a different formula, okay? So it's the same formula but with the subtract, okay? So in this case, you're going to go a cubed minus b cubed. It's almost the exact same formula, except for the signs are different. That's all. The signs are different, okay? It's going to be an a minus b times an a squared plus an ab plus b squared, okay? So it's the same exact process, except for the fact that we're going to have a subtract. So in this case, let's look at example 2. This is a perfect cube. 27 is a cube number. What cube number is it?
3.
So we're going to rewrite this as a 3x quantity cubed. Okay, you see what I've got? The 3x quantity cubed. 27 cubed can be rewritten as a 3x quantity cubed. Thumbs up on that? This is a perfect cube number. What is it? 2. So this is minus a 2 cubed. So what I'm going to do is this. I'm going to let my 3x be my a value, and I'm going to let my 2 be my b value, and I'm just going to plug those into my formula, right? So instead of writing a's and b's, I'm writing 3x's and 2's. Instead of writing a's and b's, I'm writing 3x's and 2's. So my answer is going to look like this. Okay, parentheses, parentheses. Okay. I'm going to go a minus b. Well, 3x minus 2. It's pretty easy, isn't it? A squared. Well, I'm going to take 3x squared. How about 9x squared? You okay with that? I need a squared 3x squared is a 9. Don't forget the 9x squared. Where'd the 9 come from? 3 squared, thank you. Yeah, don't forget the 9. So this is, we know 3x squared is a 9x squared, okay? Now, plus AB. AB, that's 3x times 2. Plus a 6x. Plus b squared, which is 2 squared, which is a... Isn't that easy? Thumbs up? Okay. Keep in mind, it is a different question than this, isn't it? This is a totally different question. Do you see the difference on the parentheses? This is multiply it out, multiply, multiply, multiply. It's a totally different question. We're not doing that. We're factoring, okay? Kids mess those up. Yeah, Daisy, question.
So, why did we just simplify it instead of just leaving it 27x?
Oh, you asked such good questions. Yeah, great question. Okay, so what we're going to eventually get to in here is, do you remember how we did division of fractions in Algebra 2? No, this is the wrong class. Yeah, we're going to eventually get into division of fractions. And with division of fractions, you sometimes need to be able to cancel things, right? So if you could factor first and cancel, that's one question. Second reason is if I want to find the zeros of this equation. The zeros, okay? If I want to find the zeros, then I've got to be able to set this equal to 0. One of the zeros would be 2/3, right? And the other zeros would come from quadratic numbers, okay? Good question. Okay, now, we did do this in geometry, factoring by grouping. At least I'm hoping you did this in geometry. Okay, by grouping. If you see 4 terms, group them. 4 terms, pair them up. 4 terms, pair them up. I'm going to put these 2 together and these 2 together, okay? 4 terms, pair them up. And now we're going to common factor. Now, I don't, hopefully you guys, somebody's going to say, oh, I remember this. I'll cross my fingers. Okay. Cole, I'm hoping Cole and Saul are going to say, oh, yeah, I'm serious, I remember this.
Oh, yeah.
Good. So, right off the bat, oh, Lavi had me for geometry. So what do these 2 have in common, the first 2?
X squared.
Yeah, let's take out an x squared. So if I take out an x squared out of the first 2 terms, what's left over?
X minus 3.
X minus 3. Okay, I'm going to go slowly. If you've never seen this, I'll go slowly. Some of you guys have done this before, right? Ashley, remember this? So, they have an x squared in common. I pair them up. Took out the x squared. What's left over? X minus 3. If you're unsure, you can always double check by multiplying through, and sure enough, it works. Okay. Now, the other 2. What do these 2 have in common? A positive 2. Yeah, you're ahead of me. I like that. So then if I take out the 2, I get an x minus 3, right? So then, we can factor again. Factor again. So factor again. Between these 2 groups, what do they have in common?
X.
So you have a parentheses, x minus 3, right? Now, when I pull it out of both, okay? I pull it out of both, right? So when I pull it out of both. I like to cross them out so it doesn't confuse me. And then what's left over? An x squared plus 2. So I pulled out that. Now, if it confuses you why there's 2 of them here and only 1 there, does that confuse you a little bit? Okay. Then I can show you an example real quickly over here. If I have a AB plus an AC, what do these 2 have in common? An A, right? But I only wrote 1A, didn't I?
Yes.
Because I can multiply back through and get the 2. Okay, same thing here. I pulled out an x plus 3, right? I only wrote it once because I could bring it back in, right? Thumbs up?
Yeah.
Okay, let's turn the page. There's more on the back. Okay, example 4. All right. What do you think? Any ideas? Any ideas?
Just skip it and call it good.
Anybody?
Google it.
Yes, well, I agree. Let's factor. What do you mean? You might be on top of something. You might be there. Okay, any ideas? Okay, let me help you. Okay. What times what would make an x to the 4th?
X to the second.
Yeah, let's go x2, x2. What times what makes 36?
6 and 6.
6.
6 is 6, yeah, but that's not going to make it 13.
Negative 13 and 2. No, wait, that's not right.
That's okay. Alvarado.
9 and 4.
Thank you. How about a negative 9 and a negative 4? Because
Double negative.
double negatives. And we know, if you're watching, here's a negative 4x squared. You see negative 4x squared? Here's a negative 9x squared, right? Negative 9x squared, negative 4x squared makes a negative 13x squared, right? Good, nice job.
Mr. Davies.
Okay, now, am I done?
Just blows my mind.
No, I'm not done. I can factor again. Okay, so how about x plus 3, x minus 3? How about an x plus 2, x minus 2? All right. All right. Okay. Let's look at our journal on page 78, okay?